Okay, welcome. Thanks for coming. This is the week 3 webinar of the stats class. So hopefully you're starting to get used to what the class is and what these webinars are about. So let me tell you the plan today. What we'll do is always, I'll start out if you have any questions. I always have one eye open on the chat box. And also you can talk if you want, but that's recorded, just to let you know the chat box is not officially recorded. So any questions you have, I'll be happy to answer them. Then we're going to review discrete and continuous variables. We talked about those in week 1, but now we're really going to be looking at them. So it's good to review them. Then we'll look at probability distribution tables. We'll mostly do that using some examples and seeing how to create probability distribution tables from a given scenario. Then we'll look at the expected value and standard deviation for these examples. And again, I don't expect you to all understand all that yet, but hopefully by the end of the hour you will. Then we're going to move on. We're going to look at the binomial distribution. So we've already had, we've talked about the normal distribution a little bit. But really the binomial is the first distribution we're actually going to do computations for. Then we'll look at continuous distributions in general and talk about what they mean. And then we'll look at the uniform distribution. That's a continuous distribution, and that one turns out to be the one continuous distribution we actually can do without using a hardcore calculator. That's why we talk about this one, because it's a nice way of kind of seeing what's really going on. So that's the point of this one. And we'll also look at the mean and the standard deviation when we have a uniform distribution. So that is the plan for today. I want to remind you all, this is week 3. What's important about the number 3? Put in the chat box or say it. What's important about the number 3? Why should you be a little relieved? Yeah, it's an odd week. There's no exam for this week, but you're still going to have to do the discussion post. You're still going to have to do, in this case, chapter 4 and 5 exercises. Okay, and the secret word quiz, which if you watch this webinar, then that'll be really easy. So it isn't one of the heavier weeks, but because it's not one of the heavier weeks, I strongly recommend you spend that extra time getting that project work done. Because the last webinar, we talked all about what to do with the project, and now it's time to start working on it. So what I really hope you all do, maybe within the next week, is first meet with your partners, however you'd like to meet, online or whatever, and then come up with an idea for the project and then post on the Project One discussion board your idea, the survey question you're going to ask, the population, how you're going to conduct your sample, and who your client will be. Those are the things that you should put on the Project One discussion post. Strongly recommend doing that this week so you can get a good start. And then I'll look at it and I'll let you know if it'll work. I'll give you suggestions if it needs a little fixing. So that is the plan for today. I want to introduce Hector. So Hector is our embedded tutor. Hector's taken the stats class and is here to help you out. You want to talk?
Hey everyone. Yeah, my name is Hector. I will be the embedded tutor for you guys for the quarter. And just letting you know that whatever you need help with this class, for this class, you can talk to me. I can help you with questions from the homework you're struggling with, um, your projects, or anything you have in mind. You can talk to me, and my hours are posted in the syllabus of the course. But in case you haven't seen them, I work at the library and online, and I'm there from 9 a.m. to 5 p.m. Mondays and Wednesdays, and also on Sundays I'm there from 3 to 7. And you're free to just um, come whenever you like to the library, or you can knock on door using the Cranium Cafe, or if you like, you can email to me that you want to set an appointment, and I can make a Zoom call with you, and we can work together.
Hector, can you pop your email in the chat box?
Yeah, sure.
That way they have it. And that won't be posted on YouTube, so it's
Yeah,
not all public, but at least it's public to the people who are watching right now.
yeah. So there's my email, and yeah, you can feel free to email me every time you need help, and I'll be there to assist you.
Thanks, Hector. Thanks, Hector. And he's real helpful. So, please take advantage of it. It's free. That's always a good price.
Yeah, and there are also other many tutors in the library who also work online, so you can use that definitely.
Great, great. Thanks a lot, Hector.
Yeah.
Okay. Any questions from y'all who are on? Always happy to answer questions if you have them. Okay. If you end up thinking about questions, please post them in the chat box and I'll answer them. Let's talk about chapter 4. So chapter 4 is on discrete distributions. And first, it's important that you remember what a discrete distribution is. So a discrete variable is a quantitative variable. Remember, a quantitative variable means the outputs of the survey, or what you're measuring, are numbers. So they're going to be numbers, and whose set of outcomes can be displayed as a list. So, there's lots and lots of examples of discrete variables. So, for example, if the survey question was, how many siblings do you have? Okay. You could list all the possible number of siblings someone can have. That's not hard. It's not even that long a list. Or another one might be something like, I don't know, how many pairs of shoes do you own? Okay. Again, you could list all of that. You could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe even halves, because maybe you lost one, you only have a half a pair left. But you can't have a third of a pair of shoe. So discrete variables are when you can list out all of the possible outcomes. Okay. And they must be quantitative. Okay. So the outcomes are numbers. They're not things like, what's your favorite color, where the outcome would be blue, red, green. Those aren't numbers. Okay. Quantitative variables that are not discrete are called continuous. Okay. So those where you can't list all the outcomes, it just couldn't be done. Okay. The pure definition is too hard for me to explain because you need to be a math major to fully understand it. But what I want you to do is really understand when it's discrete and when it's continuous, based on examples. And we're going to be doing both today, discrete distributions and continuous distributions, or discrete variables and continuous variables. Okay. So big deal is, for discrete variable, you can make a probability distribution table, which we're going to see some of those by example. One thing I like to remind myself and remind y'all is, if the question can be asked with the words how many, that would be discrete. Typically, if it can be asked with how much, that would be continuous. Okay. So how much time did you spend, in a car today? That's continuous because, I spent, 23.10753731214 minutes. Okay. in a car today? So notice that there's no way you could list every possibility of how long were you in a car today. Does that make sense? Okay. So how many would be discrete because that you can list, that's a number answer typically. Okay. Any questions on that idea before we actually use it? Okay. And by the way, for the project, you're welcome to use discrete or continuous. Okay. You can use a discrete variable or continuous variable. They're both okay for the project. What you can't use is a qualitative variable. So no yes, no questions, no questions where the answers are numbers. You know, so that's the important thing about a survey question. Make sure the person's output, what the person's going to say after you ask the survey, will be a number. Okay, so now it's time for an example. Okay, so here we go. Okay, a car salesperson gives out a $10 gift to every customer who test drives a car. Okay, I don't know if you've, ever had that happen with you, but often they'll give you like a little prize to test drive. Let's suppose that 12% of all customers who test drive a car purchase the base model of the car, resulting in a $200 commission for the salesperson. Okay? And by the way, the salesperson has to pay for the gift, no matter what. 8% of all customers who test drive the car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay? And I'm not sure if you've ever bought a car or sold a car, but that's how it works. Okay? They make money when you buy a car. If you don't buy a car, they lose. Okay? They lose whatever they gave you or whatever time it took, whatever it is, they lose. Okay? Any questions on the question? Okay, what we want to do is we want to analyze this and we want to see, is this a good job, for example? Right? Is it high paying? Is it low paying? Is it you just like spending money by working? Just by reading this, what do you think? Any thoughts? Put it in the chat box and tell me what you think. Just by looking at this, what's your guess? Give you a moment to type. What do you think? Okay. You think it might be losing money? Okay. Okay, we'll see. We'll see. So what we're going to do, and this is very important, like I said, statistics is very useful. And in business, you need to understand this stuff or you're not going to make a profit. Okay? You're going to have, terrible business. But if you understand it, you'll figure out whether this is something that's worthy of doing or not. And if it's worthy of doing, you do it in business. If it's not worthy of doing, you don't do it. So here we go. Let's look at the profit. Let's start with the probabilities. So the probabilities, first thing, 12% of all customers purchase the base model. So one of the probabilities, and you always want to turn percents into decimals when you're writing as a probability. So one of the probabilities is 0.12. Everyone okay with the 12% is 0.12? Okay, and I'm going to use a comma just to separate it. Okay, another probability is 8%. Those are the ones who purchase the deluxe model. 0.8%. What's that decimal? How do you turn that into a decimal? What's 8%? Put in the chat box. And some people make mistakes on this, and I want to make sure you don't. And if you're watching this on a, recorded, write it down. What do you think the percent? What do you think the decimal would be? Put in the chat box. What would 8% be as a decimal? Yeah, 0.08. So it's very important you move the decimal place 2 over, and that's going to pop that 0 in. Is that all that can happen? The only thing that could happen are base model and deluxe model. Can anything else happen? What do you think? Or am I done? Have I listed all the things, all the probabilities? Yeah, they don't buy anything at all. Okay. So let me also look at the profits. What's a profit for if they buy the base model? What profit are they making? What profit is this salesperson making if the customer buys the base model? Okay, it's not $200. Okay, that's why I asked because I want to make sure. It's good that you got it wrong so I can like emphasize what the problem is. That's not the profit. That's the commission, but not the profit. Any ideas? Okay, the idea is they had to give the $10 gift. Okay. If you have to give a $10 gift and but then you made $200 for commission, then it's $200 minus $10, which would be $190. Any questions on that? Is that clear that that's the profit in this case? So it's very important you read the question right. Okay, similarly, the profit for if they buy the deluxe model, which is that 0.08 probability, that profit will be $300 minus $10, which is $290. If they don't buy a car, what's the profit? The customer comes in, test drives, and said, "Nah, I don't like it." Walks away. What's the profit? Maybe you put the chat box. What is the profit in that case? It's not $10. That might be the profit for the customer, but the salesperson had to pay $10. So it's negative $10. Is that clear? It's not $0 either. It's negative $10. It's a loss. Is that clear or is that confusing? Because y'all had trouble with it. Do you see why that's the profit is negative $10? Any questions? Okay, so it's very important you get those little pieces right. If you get one little piece wrong, your calculation will be wrong at the end. All right. Now the total probability is always 1. Okay, that was something we had last week. That if you add up all the probabilities, you have to equal 1. So that means 0.02, I'm sorry, 0.12 plus 0.08 plus the probability of losing $10. We don't know that probability. Let's call it X for now. That is equal to 1. Okay. So that tells you that 0.12 plus 0.08 is 0.20. 0.20 plus X is equal to 1. So what's X? What's X in this case? In the chat box, what would X be? If 0.20 plus X equals 1, what's X? Ideas? A little bit of math, nothing too severe though. Not sure, maybe I'll work on it. So we can subtract 0.20 from both sides, and we get x equals 1 minus 0.20. And 1 minus 0.20 is 0.80, or 0.8 if you want. Any questions at all on calculating the profit or the values of x? Okay, or in the probabilities. In fact, maybe instead of x, probably should call it p for probability. Better than the letter x. Doesn't matter what letter we call it because we're not going to use it. Okay, so now we're going to make what's called a probability distribution table. And a probability distribution table really has two pieces. It has the values and it has the probabilities of those values occurring. Okay, the values are often called x, and p is used for probability. So now we've already done the work. Now we just type them in. So the values are 190, 290, and negative 10. The probabilities are 0.12, 0.08, and 0.8. Any questions at all on creating a probability distribution table given the information we were given? Any questions? Okay, because that sometimes can, you got to know to do it. Okay, once I have the table, now what I need to do is I need to do a computation. Okay, I'm going to find the expected value and the standard deviation. Any guess on how I'm going to do that? Any thoughts? Hopefully by now you're used to it. Yeah, we're going to go to the calculator. So if we go to the calculator, you'll notice number 6 is expected value and standard deviation. I'm going to click on that. And it's got x and p of x. And by the way, I want to let you know that you could either let it be columns or rows. It doesn't really matter for the x and p of x. So like this uses columns just for space reasons. And in my example, I use rows for space reasons. So now I got to remember my x was 190, 290, and negative 10. 190, 290, negative 10. And the p of x was 0.12, 0.08, 0.8. Any questions on typing in x and p of x to find when we want to find this? Any questions? And nothing tricky. I tried to make the calculator easy. Okay. And then it says leave the bottom rows that do not have any values blank. Okay. Also note, do not use commas in your entries. That's important when you have really big numbers, like, a million. Don't type in 1, 0, 0, 0, 0, 0, 0. Just type in 1, 0, 0, 0, 0, 0, 0. So don't ever use commas. It just messes up the computer reading if you use commas. And then I just hit calculate. And there we go. There's the expected value, 38. So our expected value is 38. And our standard deviation is 98.4683. And probably, given that we're talking money, how about 2 decimals? Because that's to the nearest penny, which you probably don't even care about a penny, but hey. So 98.47 rounded. Okay. So this is very important. I strongly recommend getting a piece of paper down and writing this out. And this is a template for the expected value. Okay. And it says if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Okay. And I put in many, likely, average, and close to in red to highlight them. And this is very important. Any guess on why I highlighted them? Any guess? See, I'll jump it in. Okay. The reason is they're absolutely required. If you do not have those words when I ask you to interpret the expected value, I will take a lot of points off. And for a couple of reasons. One is it forces you to watch this webinar. The other is that if you use AI to do your work for you, it will not give you these words and you'll lose a lot of points. So this forces you to actually learn instead of just use AI. So that's just a note. There's all kinds of ways I can test to see if you're using AI, and this is one of them. AI will not know to use those words. So write them down. Make sure that you're ready for it. For the discussion post for next week's exam, it's going to happen. Okay. So now we can write our interpretation. If many customers come to test drive a car, then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. Okay. So what do you think? Do you think this job pays okay or terrible? How long do you think it takes to test drive a car? And again, this isn't a math question. How long do you think it takes to, if you're a salesperson and someone comes in, you let them test drive the car and 5 minutes? Actually, it's a lot longer than 5 minutes. Because remember, you have to say hi to them, you have to give them that gift, you have to put them in the car, then ride around a while, and then talk to them after. Okay. It might be more like 20 minutes. But check it out. If it's 20 minutes, that means that you'll have three customers in an hour. $38 times three is what, 114. Is that pretty good money? $114 an hour? Good job or not good job? What do you think? Yeah, in terms of it pays pretty well. Okay. Okay. And by the way, if you get the job, I made these numbers up, so I don't really know how much, what percentage of people buy cars and stuff. I'm a teacher, I'm not a car salesperson. My brother was once when he was in like college for a summer, I think. But I don't really have any. But point is, if you did this work and if you did the math and you found out the statistics, you found out that was the expected value, then you say yes. Okay. On the other hand, there is an issue. The standard deviation is $98.47. Notice that's a lot higher than 38. So that means there's a big fluctuation in your earnings. Okay. So since the standard deviation is high, we should recommend that the salesperson have some money in the bank to afford basic needs for the days when the salesperson doesn't make money and maybe loses money. Does that make sense? In the long run, okay, And here's that word many. Many means the long run. In the long run, the salesperson is going to make pretty good money. But there will be little short periods where the salesperson might even lose money. Do you see how that works? And there'll be short periods when the salesperson does amazing. And that's what the standard deviation tells us is that it goes up and down in a big way. Any questions on that? Okay, let's do another example. And this is an example that happens a lot, a common example at least. And let's suppose you've been offered a life and dismemberment insurance policy, okay, that costs $1,000 per year. The policy pays the heirs $100,000 in the event of your death, okay, and $50,000 in the event of dismemberment. And I'm not sure if you know what dismemberment means. A lot of people don't know. Anyone know what that word means? Any ideas? It's not a math word, it's an English word. Yeah, possibly lose a limb, maybe an eye. Basically have, some big injury that's not good, but you don't die. And that's dismemberment. Okay. And the insurance policy is going to give you some money for that because it's not good for you. Okay. The actuaries are people who do this calculation, have determined that you have a 0.3% chance of dying this year. Just a very small percent chance, but it can happen. And a 0.5% chance of dismemberment. And let's find the expected value and standard deviation and do all the work. Okay, so we're going to do the same thing. I can go a little faster because it's really the same idea. We find x and we find p of x. Notice that if you die, then your heirs get $100,000, but there was a cost of 1,000. So that'll be 99,000. And I'm not going to use a comma just to get you used to the fact that you don't want to use commas in the calculator. Okay, if you have dismemberment, then you're going to get $50,000, but there was a cost of 1,000, so that's 49,000 left. Any questions on that? Okay. On the other hand, what else could happen? What's the other number for x? Very similar to the last one. What's another possibility? Yeah, negative 1,000. You don't die, and you're not dismembered. The probability of your heirs getting 99,000, what is that as a decimal? If it's 0.3% chance, what do I write for my p of x? Put in the chat box. Yeah, don't forget to move the decimal over 2 places. A lot of people make that mistake. And you get 0.003. Similarly, if you have a 0.5% chance of dismemberment, that's 0.005. If I take 0.003 plus 0.005, I get 0.008. And if I take 1 minus 0.008, which you're always allowed to use a calculator if you need to, you get 0.992. By the way, this is one of those, would you rather win the 99,000, win the 49,000, or lose 1,000? What would you rather have? What's better? What's the best thing that could happen? Which value of X do you want? Yeah. This is one of those weird ones is that when you buy that kind of insurance, you want to waste your money because the last thing you want to do is die. Yeah, I hope you don't want to die. And you certainly don't want to like have your arm chopped off. So it's one of those you hope for the -1,000, but you don't want to waste money either, but you'd rather have the -1,000. So let's put into the calculator. 99,000, 49,000, and -1,000. I'm gonna just hit the refresh button. I think that's the easiest. That clears everything out. 99,000 and then 49,000 and -1,000. Then the probabilities were 0.003, 0.005, and 992. And hit calculate. My expected value is -$450. And the standard deviation was, I'm going to go to the nearest dollar, $6,496. Okay, so notice this is a case where, in terms of the purchase, your expected value is negative. By the way, with insurance, why do you think it's always negative? No matter what insurance company you ever go to, whether it's life insurance or car insurance or homeowner insurance, why is it always negative? If you calculate the expected value, it'll always be negative. How come? In the real world now. Thoughts? So you always pay, but the reason is that there's a business called an insurance company, and they would never let the expected value be positive because then they'll lose money, and the business's goal is to make a profit. So what they do is they calculate the expected value and make sure that it's a negative amount so they make the right amount of money for them. Okay, so that's how business works. On the other hand, the standard deviation is very high. Okay, so that's one of those where if you happen to, if you have a small child, then maybe it's a good idea, and maybe you're the breadwinner of the family. Maybe it's a good idea to buy insurance because if that very small chance of you dying happened, that child is going to really be lost. Okay, so there's reasons, even with the expected value being negative, to buy insurance. On the other hand, if if you have no heirs, you have no relatives or something, then this would be silly to buy life insurance because why waste money? Any questions on this idea? Okay, and I'm going to say the interpretation. I'm not going to write it, but I'm going to say it. That would be, you could think of as if many people purchase this insurance, then it would be very likely that the average loss per person for the insurance would be close to $450. And notice if I use the word loss, I don't have to have the negative because that's English. Any questions on expected value and standard deviation? Okay. Any guess on where I use expected value, where I've used it in my life? Any guesses? With my job, actually, I don't. I mean, other than teaching expected value, but that's not really using it. That's teaching it. So let me tell you, you may not guess, but when I was younger, okay, when I turned 21, what do you get to do when you turn 21? It's two things you get to do. And here's a hint. The one that matters is the fact that if you live here, you would know that in Tahoe. Any thoughts? Don't see y'all jumping in. You get to gamble. Okay, you get to gamble. And what I was able to do is I was able to, at the time, the rules were different. I was able to do mathematics while I was gambling throughout the whole time and have an expected value of about 5% per dollar I've spent. And I would be there. I play many, many, many games. That's important for the rules. And when I played many, many games, on average, my return was very close to that 5% expected value, which means by the end of the day, I made a lot of money. Okay. Eventually, I had to quit because they would have killed me. But other than that, I would have played more. Okay. But when I got to Tahoe, that was in Vegas. I used to do that. But when I got to Tahoe, they hired me to help them change the rules so that the expected value is no longer positive. Okay. So it's my fault now. So more money. So expected value is very important in making money, but it's used for other things too. All right. Let's get to binomial distribution. Okay. So now a binomial distribution comes from multiple independent trials of a yes-no question, okay, or yes-no style question, and measures the number of yes answers. Any questions on the definition before we do examples? Okay, let's do some examples. Okay, this is one of the I think it's a very important example. Hopefully, hopefully you've heard of climate change. And one of the things that I think is very important is understanding statistics so that you can know whether or not climate change is real or it's just something that a bunch of people are saying, talking about, but it's just a joke. Okay. And we don't need to worry about it. Okay. So the key on things like climate change is see statistically, are we in climate change? So here is, and by the way, unlike some of the other examples I give you, this one you can quote me on. Okay. There have been 175 years in recorded history of global temperatures. Okay. And I actually found that I found it in three places. One was Wikipedia, by the way. And 175 years, they have been recording the average global temperature for each of those years. Okay. In the next 20 years, if weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 175 years. Any questions on the question? Okay, notice that kind of the survey question, what you're going to ask the year or look at that year is, are you in the top 10 or are you not in the top 10? Does that make sense? And it's a yes, no question for 20 years you're going to ask. Any questions on the idea? Okay, so N here, N will be the number of trials, and we're looking at 20 years, so N is 20. Any questions on that so far? Okay, so we're going to say that, hey, if we're assuming randomness, and that's really important, if we assume that there's no climate change, every year is just randomly happens, then the probability of any particular year being in the top 10 of the prior 175 years will be 10 divided by 175. And that's how probability works. It's a fraction where the numerator is how many ways it can happen. There's top 10 means there's 10 possibilities. And the denominator is how many different things can happen. That's 175 years. Okay. We want to find out what is the probability that x is greater than or equal to 10. Any questions on that? All right. So how do you think I'm going to find that probability? Notice we have a binomial distribution because each year is a yes/no question. Is it in the top 10 or is it not in the top 10? And we have, 20 years that we're doing. So any guess on how we're going to find that number? That probability? Hopefully it's obvious by now. Because now we're in week 3 and we've done it a bunch of times. How are we going to find the probability? Don't see all you jumping in. Okay. Maybe I'll tell you. Go to the calculator. I'm going to go back to the calculator menu. And you'll notice, remember, we do things in order. The calculator goes in order of how we do things in class. And we just did expected value, and next is binomial probability, because we have a binomial distribution. So I'm going to click on binomial probability. Any questions on that? And what it's going to ask for is the low, the high, trials, and p. The lower bound for the number of success, that's low. Upper bound for the number of success is high. Number of trials, and the probability of success. Then we hit calculate. So, what's the low? If we want the probability that x is at least 10, what's the lowest number that could be? It's very obvious. That's a hint. 10. Yeah. What's the highest number that could be? That would be 20. That would mean every year is in the top 10 as we go. Okay, every 20 years. Remember that we're just looking at the past 175 years. So that all 20 could be the top 10 because maybe, the first 10 were lower than the last 10, but they were all high. Does that make sense? Number of trials is 20. And the probability of success was 10 over 175. And that's what we put in the calculator. So I'm going to go 10 for the low, 20 for the high, 20 for the number of trials, and P was 10 over 175. I'm going to click scientific calculator and type it in. 10 divided by 175. And it's 0.05, etc. I'll just copy and paste it in. It's the easiest thing to do. And I hit calculate. What do I get? 0. So that actually turned out to be 0, which means such a low number that the calculator can't even handle it. It's less than 1 in a million chances. Okay, so it rounds to 0, however many digits the calculator gives. So what does that tell us? If you have a probability of 0 and it happens, what does that tell you? Any thoughts? And this is real, by the way. I like to give this because this is like using math to totally understand what's going on in the world. Okay. Yeah, it means right here, assume randomness is wrong. It is not random. Okay. And I like to, give this as a statement. What's the first three letters of assume? Yeah. And then the word assume is UME. So makes an ass out of you and me. So you assuming means, and you get a probability of zero, that means it was just wrong. This is not random. The fact that, we have had such warm weather is not just because of random chance. Okay. So then you go and do science. And that's what statistics is all about, is you find out that mathematically things shouldn't happen the way they're happening. So then you go to the scientists and have them figure out what's going on and what's wrong with this assumption. And what they did is they looked at all the different things that could make it warm. And the only item that we have that has scientific evidence to make it warm is carbon dioxide in the atmosphere and methane. Okay, so that's really, there's nothing that scientists have found that could make that happen. There are other things that could make it happen, but aren't happening. Things like solar flares, but we have satellites looking at the sun and we're not getting extreme solar flares and things like that. The only thing that they've ever found that could make that happen is what we're doing to the atmosphere. And that's where you got to understand science and statistics. It's a combination of the two helps us understand the world. Okay. I don't have a solution necessarily. I'd love it to not be terrible, but we should understand that we can do our best. Part of that is less carbon dioxide in the atmosphere. And that's just a note. And that is statistics and science. Okay. It's not religion or anything like that. It's statistics and science that shows it. Any questions? This is I think, one of the most important examples of statistics there is, period, in this class or in any class. Hopefully you agree. Okay. Let's do another example. Okay. And oh, by the way, I looked it up today. They just came out in the news about the global temp from 2024, because we're not far away from that anymore. And 2024, any guess in terms of its rank in terms of temperature in the last 175 years? What last year was in its rank? Any guess? Top four? Even more so. Top one. Last year was the highest temperature on average global temperature of in the last 175 years. And it turns out in the last 10 years, all 10 of them have been in the top 10. So it's even more than I said here. But I wanted to do an example where the low was smaller than the trials. Otherwise, it's just all 20s. Okay, it was 10, 10, 10. You still get P equals zero, by the way. Okay, yeah, we're there, unfortunately. Not good news. Sorry to be the bad guy. It's not my fault, I promise. In fact, as I mentioned in my Two Truths on One Truth, I don't know if y'all read it, but how many times have I driven to work in the last 10 years to the college? You all read it? Zero. Okay. I never drive to the college. I walk or ski. Unfortunately, I haven't skied in a while because we have no snow, but I walk and that's part of the reason is it helps with climate change. Okay, so we can all do what we can. All right, so let's look at another example. Okay. 24% of people worldwide feel lonely. Okay. This was based on a study that was done. If 17 randomly selected people are surveyed, we're going to do a bunch of these. What's the probability between 5 and 10 of them feel lonely? Okay. So, first thing, the question is, do you feel lonely? The answer is yes, no. So, this is binomial. Between 5 and 10 means the low is 5 and the high is 10. Any questions on that? Number of trials is 17 because they asked 17 people. P, okay, the probability of feeling lonely is 0.24. That's 24. That's 24%. So now we just go to the calculator. I'm going to refresh, and that'll pop in all the numbers again. And we just plug in the numbers. Low was 5, 5, 10, 17, 24. So 5, 10, 17, and 0.24. And we calculate, and about 0.3875. So around a 39% chance that between 5 and 10 people out of the randomly selected 17 will feel lonely. Any questions on that? Okay, at least 6 of them feel lonely. Okay, in this case, the low is 6. The high is 17 because at least 6, the highest number that can be at least 6 is 17 because we asked 17 people. If everyone was lonely, then all 17 of them were lonely. That's the highest. So it's just 6 and 17. And the good news is I just put those numbers in. 6, 17, and same trials in P, and I calculate. And it's about 20%. Any questions on that? Okay, the third one is fewer than 5. So now the lowest number less than 5 to feel lonely would be 0. Here's a note, fewer than 5, we have a discrete distribution. The highest number that's fewer than 5 is 4 for a discrete distribution. And all the rest is the same. So we're going to have a 0 and a 4. And hit calculate, and it's about 61%. And then finally, exactly 5 feel lonely. What's the lowest number to be exactly 5? This should be easy. 5. What's the highest number to be exactly 5? 5 again. So if it's exactly a number, the high and low will be that number. Hit calculate, and about 18%. Any questions on this example? Okay, now we're going to move on to the continuous distributions. Okay. So what is the shape of this distribution picture that I've got here in one word? We talked about this 2 weeks ago. What's the shape of what I have written of this guy? In one word, that's a hint. Do you remember? It's the most important distribution there is in all of this class, by far. On a scale of 1 to 10 of importance, it's a 10. And it's the only 10. What's the shape? Do you remember? I don't see you typing it in. It has a shape. Normal. Do you remember that? Okay, this is a normal distribution. I'll let you know that a normal distribution is a continuous distribution. You cannot make a table of all the possibilities. You can't do that. It's continuous. And if you want to find a probability, then you're finding the area between the low and the high under the curve. I will also let you know that if you want to find that probability and need to do it by hand, you need to take calculus, a lot of calculus, and we're not doing that in this class. So we will find the probability, but we're going to use a calculator only. Okay, and you're just going to have to trust it, which I've coded, so you can trust me. Okay. So on the other hand, the easiest distribution, which isn't the most important, but the easiest, is called the uniform distribution. Okay, it has a low and a high, a uniform distribution. Okay, it's continuous, and it's such that any two given intervals of length k that is contained between A and B has the same probability of occurring, and any other interval outside has zero probability. Okay, we'll see how to use that in a bit. Okay, and the distribution curve of a uniform distribution is a rectangle. Very important. Okay, who remembers the area of a rectangle? What's the formula for the area of a rectangle? See if you can put in the chat boxes. It's very important for this chapter. What's the area of a rectangle? It's the math formula. Nothing too fancy. Remember, it's the easiest area formula there is. So what is it? You probably learned it in 5th grade. I have no idea how old any of you are, so who knows? Could have been last year, but I doubt it. But what's the area of a rectangle? Yeah, length times width. Okay, sometimes I'll use base times width, base times height, for a couple reasons. One, L looks too much like a 1, and that could get confusing. And the other is in a picture, we're going to be using height because it's going to be up and down, and base is the left and right. Okay, if it's uniformly distributed, then the symbols we're going to use, we're going to have x for the variable. Who knows what this little symbol is? And it's the funny thing is, if you understand Spanish, you've used it a lot, and it's every keyboard has it, just about. But a lot of people don't know how to say it. No, maybe you don't know. It's called tilde. That's called a tilde. And U is the first letter of the word uniform. So we say X tilde is like has a uniform distribution from A to B, the low of A and high of B. Any questions on kind of writing that out? The nice thing is tilde is really easy to type because it's on the keyboard. Okay, so here's an example. Suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So I can write x tilde u 10, 120. Any questions so far on the example? Okay, if a randomly selected student who used a math tutor is observed, find the probability that that student will spend between 30 and 70 minutes with the math tutor. Any questions on the question? Okay, so what we're going to do is the first step is draw a picture. And as I mentioned, uniform distribution will be a rectangle. So I'm going to draw a rectangle. The base is going to go from 10 to 120 because we were told that. The height, we don't know yet. So I'm just going to call it H. Okay, any questions so far? Okay, now this is a probability. What's the area of the whole rectangle? The hint is it's really easy. I'm looking for a number. What's the area of the entire rectangle? What number is it? You don't have to do any calculations. That's a hint. It's very easy to type in the chat box. No, it's not 120. Good try, though. Okay, so the idea is remember that the probability of being between those numbers, 10 and 120, is the area under the rectangle or in the rectangle. But if it's a uniform distribution and everyone spends between 10 and 120 minutes seeing a tutor, then there's a 100% chance of being between 110 and 120. Or in other words, the probability is 1, and that is the area. So the area is 1. Any questions on why the area is 1 for a uniform distribution between the low and the high? Any questions on that? Okay, so we need to find this probability. So what we do is we write down the area. Remember, the area is the base times height. I'm going to use B and H. And that's equal to 1 for the whole rectangle. The base, well, it goes from 10 to 120. To find how wide that is, you take 120 and you subtract 10. The height is H. 120 minus 10 is 110. So we get 110H equals 1. Okay, and by the way, this is one of those times in our class there's a little bit of math, a little algebra, but nothing too hard. If you have 1 equals 110H, you divide both sides by 110, and you get H equals 1 over 110. Any questions on how I got that? Any questions? Okay, we're not done. We just found H. We didn't find the probability. We want the probability the student will spend between 30 and 70 minutes. So what I'm going to do now is draw another picture. So here's the rectangle now, and I'm going to go between 30 and 70. The probability of it being between 30 and 70 is the area of this rectangle. The area is the base times the height. So probability that x is between 30 and 70 is base times height. The base is 70 minus 30. The height we just found was 1 over 110. So times 1 over 110. 70 minus 30 is 40. And you get 40 over 110. And then it all depends what you want to do. You can simplify, kill those zeros, make it 4/11ths. You could put in a calculator and divide and get, some decimal place. That'll be, point, I don't know, 3 something, 3.9 or 3.8 or something like that. Okay, any questions on finding that probability? Any questions? Okay, so now let's look at another question. Find the first quartile for the time students spend with a math tutor. Any questions so far? Any questions on what it's asking for? Who remembers what it means to be the first quartile? Very important for your project, by the way. You have to understand quartiles because that's going to be in the box plot in your project. Yeah, it means 25% is at or below that number. So I'm going to draw a picture. We don't know what the number is because that's what we're trying to find. In math, when you don't know what something is, you often just give it a letter. I'm going to give it X as a letter because that's typical when it's on a horizontal axis, you usually use X. And what we do know is the probability of being between 10 and X is 0.25. Any questions on that? Okay, so now what we do is we use our formula. 0.25 is our area. That's what probability is for a distribution of a continuous variable. So 0.25 is the area. The area is base times height, b times h. The base now is from 0 to 10, the base will be x minus 10. Just like over here, we said 70 minus 30 when we knew the numbers. We subtracted. Well, we're still going to subtract, but now we don't know x, so we just call it x minus 10. The height was 1 over 110. So now we have 0.25 equals x minus 10 times 1 over 110. And now algebra. We're going to multiply left and right by 110, and you get x minus 10 equals 0.25 times 110. Then I'm going to add 10 to both sides, and I get x equals 0.25 times 110 plus 10. And that's 37.5. And there is my first quartile for the time spent with the math tutor. Any questions at all on this example? Okay. All right. I'm going to do this one a bit fast because we only have so much time and I still have one more thing to talk about. So let's suppose we have a bunch more. A statistics instructor will be giving extra credit to students in the top 8% based on how long they spend with a math tutor. At least how long must a student spend with a math tutor to get extra credit? Okay. So now what you're going to do, there's a couple ways of doing it. One is if you're in the top 8%, then 92% are less than you. Does that make sense? Because 100% minus 8% is 92%. The reason why I'm doing it that way is that it's going to allow us to do it just like the quartile example. So now what we can do is we could say 0.92, that's our area, is base times height. And that was, the base was x minus 10, just like we did before. The height was 110. I multiply by 110, and I get x minus 10 equals 0.92 times 110. And then I add 10. And it's 0.92 times 110 plus 10. Any questions on that? Okay. I think I'm not going to do these last ones. I always have them just in case. Okay. But except F. I want to do F because that's easy and fun. What is the probability that a student spends exactly 25 minutes with a math tutor? Can you tell me? The hint is it's really easy. It's not 1 over 25. Let's take a look at the picture again. If you're exactly 25, what's the low if you're exactly 25? What's the high? So how far is the base from low to high? 0. So what's the base times the height? So the hint is it's really easy. It's not 50. If the base is 0, what's the base times the height? What's 0 times anything? 0. So there's a 0 probability of spending exactly 25 minutes. Okay. And by the way, any number they gave, if it was exactly 30 minutes, it's still a 0 probability. When you have a continuous distribution, the probability of being exactly something is always 0. Doesn't mean it can't happen, but it means that there's a 0 probability of it happening. It's a little complicated. All right, so the last thing I want to do is talk about the mean and standard deviation. The first thing, this is kind of obvious, I hope. What do you think the mean is? How do we find the mean for this example when we have this distribution that's a rectangle that goes between 10 and 120? How do I find the mean? Any guess? It's kind of easy. That's a hint. It's something you learn when you're in elementary school. That's a hint. You didn't use the word mean, you use the word average. That's a hint. What is the mean? How do you find it? Yeah, you add A plus B and then divide by 2, right? Because there's two numbers. Okay, that's how we're going to find it. So now I'm going to scroll down and let you know that the mean, remember, mu is a letter we use for mean, is A plus B over 2. Okay, the standard deviation, on the other hand, if I asked you, how do you find that? Then unless you've had calculus, you have no chance other than here's the formula and write it down. And that is the standard deviation, we use sigma for standard deviation, is equal to the square root of b minus a quantity squared divided by 12. And I'm going to do this a lot in this class, and that is just believe it. Okay? Unless you're one of these calculus people, and then I'll let you figure it out. But I don't expect any of you to be able to come up with that. Okay, so that is the standard deviation. But you should know how to plug in numbers. Sound good? Into a calculator. All right, so here's an example. Okay, suppose that the number of ounces of water that people drink from a drinking fountain, okay, is uniformly distributed between 1 and 8 ounces. Okay, and the number of ounces that students use to fill their water bottle, okay, in the drinking fountain is uniformly distributed between 4 and 16 ounces. Okay, you watch Thorne take 2.5 ounce drink out of a drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Okay. Whose water uses is more unusually small compared to the rest of the people who use the fountain for the corresponding usage? Okay. And just for fun, these are actually my students. They took my stats class, Thorne and Preston. So they were people. Okay. Um, so let me ask you, in our class, what have we learned in terms of a statistic to calculate how unusual something is? What was that statistic? Do you remember? Talked about it 2 weeks ago. 2 weeks ago, almost to the moment. Remember? There was a statistic that told you how unusual something was. Rule of thumb, not quite. Here's a hint. It's a one-letter answer. Is the easiest way to type it. So if you guess randomly, you'd have a 1 out of 26 chance of getting it. But hopefully you remember. Do you remember? I don't see you jumping in. Doesn't take long to type. Z. Do you remember the Z score? The Z tells you how unusual a value is when you can get the mean and standard deviation. So what we're going to do is we're going to compute the Z score, and whoever has a Z score that's more unusual, which means farther from zero, is going to be more unusual. And usually small means a very small negative number. So if you remember, the Z-score formula was X minus mu over sigma. Do you remember that? All right, so now what we're going to do is we're just going to look at them one at a time. Start with Thorn. Thorn drank 2.5 ounces out of the drinking fountain. So Thorn's X value is 2.5. Okay, for the drinking fountain, it was uniform between 1 and 8. So mu is 1 plus 8 over 2, which is 9 halves or 4.5. Any questions on that? Okay, and sigma is the square root of b minus a squared over 12, or 8 minus 1 quantity squared over 12, square root. And that's calculator work. Don't even try and do it in your head. That's about 2.02 if you put in a calculator. Any questions on getting X, mu, and sigma? All right, now you plug it in. X is 2.5, mu is 4.5, sigma is 2.02. So 2.5 minus 4.5, all divided by 2.02. And just note, when using a calculator, it's really important to make sure that you put parentheses around the 2.5 minus 4.5. If you forget the parentheses, then it'll give you the wrong answer. Okay, because that big line of division tells you need parentheses for the numerator. And what you get is approximately equal to -1 within a couple decimals. Any questions on that? Okay, then we're going to do Preston. Same idea. Preston filled his water bottle with 5 ounces of water. So that means Preston's X was 5. Okay, for water bottles, it was uniform between 4 and 16 ounces. So that means mu is 4 plus 16 over 2, which is 4 plus 16 is 20. 20 divided by 2 is 10. And then 16 minus 4 squared over 12, square root of all that, put in a calculator, and you get 3.46. So then you put it in the z-score formula. That's X, which is 5, minus mu, which was 10, divided by sigma, which was 3.46. And pop that in the calculator. 5 minus 10 over 3.46 is equal to -1.45. Okay, so who was more unusually small in terms of the amount of water that was consumed? Yeah, Preston was more unusually small. Notice Preston drank more water, or took more water, because 5 versus 2.5, but we have to look at it based on the distribution in their scenario. Does that make sense? And when you have a uniform distribution, we have formulas we can use. So Preston was more unusually, or took unusually small amount of water compared to Thorn, compared to water, the type of water use. Any questions at all on this example of using the uniform distribution and the formula for the mean and standard deviation and z-score? I do want to give you a strong heads up for your project. You definitely have to talk about z-scores. Okay, you're not going to have a uniform distribution, by the way, but you talk about z-scores, and there's a z-score calculator in the spreadsheet you can use. You can use it to decide if you have outliers. By the way, was Thorne an outlier? Was Preston an outlier? Were neither? Were both? What can you say? In terms of outliers, got to remember what the definition of an outlier was in terms of z-score. What do you think? We had a definition. You may not remember. It's been 2 weeks, but it's important for the project too. Okay, I don't see jumping in. So remember the definition of the outlier is that z either has to be less than -2 or greater than 2. -1 is not less than -2. -1.45 is definitely not less than -2. And they're certainly not greater than 2 because they're negative. So neither of them were outliers. Okay, had it been like -2.45, then it would have been an outlier. Do you see? Any questions on the idea of kind of discrete distributions or continuous distributions? Okay. If not, what's the last thing I need to do? What do I still need to do that I haven't done yet? Got to get a secret word. The secret word for this webinar is rectangle. And I want to strongly recommend if all you did is look at the secret word, you're going to lose a lot of points on stuff where I told you you have to have those words in your answers on exam questions. So you have to watch these webinars. It is an absolute requirement. Okay. And take good notes and make sure you pay attention. Okay. So the secret word is rectangle. And that's the secret word for this week. Okay, so that's about it. Again, a reminder, please think about your project and get your project ID in the Project One discussion board. Don't email it to me, post it in the Project One discussion board, and I'll give you suggestions. Okay, and that way you can look at the suggestions I gave for other people and see what works and doesn't work if you're not the first one to do it, and then you can see what works for others and not make the same mistakes. Okay, so that is pretty much it. I'm always happy to answer questions, but I'm going to stop the recording. So thanks for watching. Those who are watching this recorded.